All right, so let's go ahead and get started. We are live on YouTube as well, and that should be kicking off very soon. All right, all right, perfect. So thanks for joining our third episode of the CircleCI's Open Circle sessions. My name is Jeremy Meese. I'm the head of DevRel here at CircleCI. A little background on Open Circle sessions. It's something that we started doing a few weeks ago, actually about a month ago, enabling the whole idea is to enable CircleCI community members to interact directly with CircleCI teams and employees to discuss all things CircleCI. It's also an opportunity for the community to learn the latest and greatest in the CircleCI universe, and also serves as a kind of that continuous feedback loop between the community and CircleCI. So thank you for joining. And if you stick around to the very end, we will have a feedback form that you'll be able to fill out. And those that stick around and fill out the feedback form, we have a free work from home kit that we are going to be kicking off to you. One lucky member will get a Logitech streaming webcam, and then also a Blue Yeti podcasting kit, as well as a CircleCI coffee mug for those mornings. So stick around and be ready for that. So with that, I'd like to turn it over to Angel.
Oh yeah, hey, hello everyone. Thanks for showing up. I'm wearing my Barcelona hat today because I was supposed to be in Barcelona this week with my family, but obviously we're not there. So I'm just celebrating a little bit in my home office and on this broadcast. So yeah, today we have Glen Mailer from our team. He's a staff software engineer, right, Glenn? Cool. I'm not big on titles, but I just wanted to get that right. And today we're going to be talking about optimizing our pipelines within CircleCI. This is something near and dear to my heart. Prior to me joining CircleCI, I actually was a user and a customer of CircleCI. So yeah, I was always, looking for that extra oomph and speed, right, to boost the velocity of my pipelines and my builds. So yeah, Glenn is kind enough to come and talk to us about how we could as CircleCI users basically improve the speed of our pipelines and get it up and running faster. So yeah, Glenn, why don't you introduce yourself a little more and let's talk about the optimizing our pipelines.
All right, cool. Hi everyone. I'm Glenn. So I work on the execution team at CircleCI, which is the team that's responsible for taking the builds and actually running them. We have this tradition at CircleCI where whenever you're in a sort of a broadcasting in a meeting or something, you share a fun fact about yourself. And I'd forgotten this until about 30 seconds ago. But my fun fact is that yesterday I tried to do a run in the shape of a capital letter I, and I failed because GPS had a bit of a blip. So there you go. But yeah, so my background is so I've been at CircleCI a little over a year now. Before CircleCI, I worked as a sort of consultant in relatively full stack, but doing a lot of work in the sort of DevOps space, and particularly around helping companies and teams improve their feedback loops, get feedback faster, and that very much included using CI and getting their builds running really fast. And so that's something that's sort of I'm really keen on now I'm here at CircleCI. So a few years ago, I did a conference called CodeMesh down in London, which is a really great conference if it still exists. I don't know what's going on these days, but yeah, and that talk was about feedback, and specifically in that talk, I was talking about feedback at 1 Hertz, so within 1 second, and it was talking about really tight feedback loops, really fast test suites, and I guess what I want to kind of talk about today is an extension of that. So how do we apply that to pipelines? There's an old if you Google for microservice testing strategies, there's one of the top results is this slide deck from ThoughtWorks a few years ago, and one of the concepts in there that has really stuck with me was this idea of a test time budget. So you decide how long am I willing to spend waiting for CI, and then you allocate that budget however you need to. And that's something I want to talk about today, really. So actually, I've got a little demo I'm just going to do now. So this is, let me make sure I get the right browser window. Don't need to just reveal all my notes. Yep, so this is a pull request here. Here's one I made earlier. But this is for one of the repos that we've got on our project at the moment. I'm just going to go ahead and hit merge there. So I did review this earlier, don't worry. We actually had one of these earlier that I was supposed to use, and then my colleague forgot and deployed it, so I had to make a new one. But the main thing I want to demonstrate here is this will kick off a new pipeline, which is going to run a bunch of tests. And if I look at this main workflow here, you can see that that is running a whole bunch of jobs and so on. It's been going for 25 seconds or so. And so in CircleCI, whenever we merge to master, we kick off a pipeline, we run a fairly comprehensive set of tests, and then if all of those tests pass, we deploy to production. And in this particular case, the budget that I set for my team was 1 minute. The idea being that like between clicking merge and actually deploying, then I want it to take around a minute. And that's what this does. And hopefully I have padded long enough so that it will reach the end and you will actually see that minute, and that will go ahead and deploy to production.
Yeah, that's a pretty stringent baseline, man. I actually like it. I used to have a 10-minute rule, but after talking to you prior to this, 1 minute's going to try to be my goal in most cases. So I like that.
Yeah, and I've got some more concrete stuff I can talk about like tips and tricks that we took to make this take 1 minute. You can see there the tests themselves took a little over a minute there, but the Docker image is just finishing off. So, well, this is a slow one.
Yeah, those are always those are always tough. The Docker images. There you go. 38
there
seconds.
We go. Right. Okay. So now the deploy is kicking on. I think the deploy takes about 10 seconds or so to run. So that'll sort itself out now.
So while we're waiting on that deep. I'm sorry. I was going to say, if you have any questions to the attendees, please feel free to just post them in the Q&A section, and then we'll go ahead and after Glen's discussing the demo and other topics, we'll start taking some live calls from you so that you can ask Glen your questions direct.
There we go. So 2 minutes. So within an order of magnitude, but double what the speed I'd like. And so this varies. I think this particular pipeline is generally between like 1 minute and 10 to 2 minutes. But it's slow enough that if you watch it, you don't get too bored, which I think is the sort of metric I'm looking for.
Nice. I like it.
So I guess if I start talking about some of the main concepts that we applied to speed up that pipeline, and I think the first one, and this isn't a CircleCI thing at all, this is like just write fast tests, which is very easy to say. Obviously, it's often harder to put into practice, and especially if you've got a code base that's been around for a while where that wasn't a priority. So in this particular case, this repository has been around less than a year, and when we started it, we prioritized like. Basically, from the start, we want to have a fast test. We want things to take it like to finish quickly. I like some of my colleagues mock me for this. I take it possibly too seriously sometimes. So I was annoyed the other day that the test suite has crept up to about 6 seconds, and I was like, this shouldn't take that long. So yeah, the first thing is like just do less, like be fast in the baseline, regardless of CI. That's a great start. And then when it comes to actually running the CI, like I think a lot of people, especially if you come from like an on-premise setup, or you've had like a limited number of concurrency or smaller builders, then you generally say you're trying to protect the CI machines from having to do things. So you'd end up with these long sort of narrow pipelines where you do the lint step, because if the lint step fails, the tests aren't going to pass. So you try and protect all those jobs from running. But because on CircleCI, like builds are really cheap. It costs something like 38 cents to run a build for an hour. And we have like really high parallelism limits. So that means you can do a lot of work in parallel. And then if something fails, just throw all the other work away. And you've lost very little, but what you've gained is you've really compressed that pipeline so things finish quickly. And that's what a lot of my strategy there is about. So we ran the linting at the same time as the testing, at the same time as the Docker build. And if the tests fail, we just throw all that other stuff away.
Right. So what you're saying is basically kind of shift a little bit left into the testing arena and the orchestration of the different tasks that you're trying to accomplish instead of sequencing them, just running them concurrently. And then I guess you would have to that's a fan out and then fan back to kind of regulate, right? So if any one of those fail, then right, the whole build goes. Yeah.
Exactly that, yeah. So on a branch build, on a pull request build, we fan out and then we don't really fan in because there is no deploy. But on a production build, that's when we've got this extra deploy step on the end, and that's got that fan in.
Right.
And you kind of see that sort of fan shape on the diagram there, where everything's like dependent on the deploy.
Yeah, and then you could even do a fan in and then fan out again if you decide to start deploying, right? Like, so if you have different, maybe multi-cloud, or you just want to store things in different arenas, like
Yeah, definitely.
artifacts in S3 or something.
Yeah, I mean, if you're doing any sort of post-deployment verification type steps, then putting those in the pipeline as well and having those on a fan out could work really well.
Yeah, I do. So I've been giving a talk about increasing your app confidence, and one of the focuses there is just talking about post deployment and doing maybe some smoke testing on a particular build, right? So if I have this application, I run all the all the tests, unit tests, all that stuff, but I don't want to get into an expensive testing regimen before I know, like, if it doesn't pass a linter or my smoke test, right? Then I should just stop there, obviously, and fix what's broken, and then go back to the drawing board and kick off that build again. But at the end of the day, you could have different layers where a job then fans out into what I was talking about was basically packaging up that app into Docker container and then throwing it into a Kubernetes cluster using infrastructure as code, testing my smoke test there, and then crushing all that infrastructure, so that, when the release comes and the release manager looks at my builds and knows that, hey, in this pipeline, this thing ran in a Kubernetes cluster on GKE or whatever platform, right? So yeah, these are different kind of tips. I definitely want to explore. I just like the 1 minute rule for myself personally. I think that's awesome. And yeah,
like, so we do have some of our stuff does do that kind of production canary type deployment testing as part of the pipeline. So we've actually got the build agent that handles the execution of people's jobs. We've got there's a privileged mode for that, so that at CircleCI we can launch builds using pre-release versions of that agent, and that's really tightly locked down for, as you can imagine, obvious reasons. But what that allows us to do is, on a branch build for the build agent, we can launch that into production against all of the other running services in production and execute some builds just for us. And then, because it's only alive for the duration of that build, it shuts down later, so there's no cleanup to do either. And that gives us a lot of confidence when we're making changes to that part of the system.
Right.
Yeah. I guess that's kind of the thing, is that, like, my general approach to testing is, I think of testing as about confidence. It's not about correctness. Like, software, like, we're not really doing like formal methods, verification stuff. Software is never going to be completely 100% correct. What it needs to be is better than the previous version. And if we just keep shipping better than the previous version, and then listening to that feedback from our tests, from our customers, from our, just from experience of using our product, then, that's how we can end up with a better solution.
Absolutely. Yeah. I mean, right. Software is always going to be changing, and I agree with that, especially when you're, like I said, you're trying to gain some velocity and efficiencies, right? Right. If you're trying to make it perfect, I think, that's a losing battle in every build, right?
I love that concept, because it kind of pushes more around the iteration of continuously, check it, see if it works. Okay, great, move on. If it didn't, all right, let's just keep iterating. I love the concept there.
Yeah, I mean, there's a bunch of ideas. I think it was originally from like the world of lean manufacturing, where you start to think about inventory, and so lean's all about keeping that inventory low and having these supply chains going. And in the software world, like, inventory is like, it's code you've started on but haven't shipped yet. Like, that's you've invested some time and cost, and then how much does it cost to hold those things? So we generally try and keep our pull requests really small, turn those around quickly. So although we do like blocking code view on each change, we'll generally, like, I saw that app I demoed today, this morning, we've deployed that 7 times, and some of the work for that was started and finished today. But this general idea, so the branch doesn't live very long, and then once you've hit merge, there isn't, like, we're not building up this inventory on master of unreleased changes. We're immediately shipping that out into production and getting that feedback. And we've got a lot of like graphs and telemetry and logging and alerting and monitoring tools that keep an eye on those changes, so that if we do manage to hit a problem, we're able to roll back really quickly. Or we can use canary deployment mechanisms so that like we can try something out in production and then we can roll it out to the rest of our customers.
Cool, cool.
That's cool. So,
I guess,
our old friend Hannah Henderson actually, thanks for joining.
She used
Hannah.
to work with us.
Hi,
she
Hannah.
just popped
Open
a
up her mic,
question.
Jeremy. Let her talk.
Let's let her ask that question live.
Yeah, Hannah. Love to hear
Hannah,
from
you
you.
should be able to talk if you would like.
Hi.
Hi.
I refrained from trolling anybody in the comments. So that's
Good. Well, we appreciate it. That's another time.
I was curious to know, for the test suite that you made faster, are there certain types of tests that that you were sort of ruthless with and removed or optimized? Because some types of tests, like integration ones, are inherently slow. Which ones are good contenders for quick wins in reducing the time to run of a test suite?
Ooh, good question.
Yeah, that's a great question. So in this particular case, I kind of cheated in that the test suite was never slow. So we just never made it slow. We just kept it fast from day zero and kept an eye on that. But certainly, like, integration tests are a great example of, so we step back from it. So I know there's some people who get really, really up about like what is a unit test and what isn't a unit test. And I am not in any way one of those people. So I don't care what a unit is. I don't care like whether something is a unit test or not. What I care about is it test fast and is it reliable? And so actually that app I demonstrated there, we've got loads of tests that hit the database, but they're not slow because we don't put a lot of data in the database. The queries themselves are pretty fast. Like it takes, and we're talking to a database on the local machine as well. So it takes a millisecond or so to round trip, like probably less than a millisecond in practice. And then there is definitely an aspect of that whole like test pyramid kind of concept where you're saying, okay, well, we've got some like acceptance level tests that treat the application as a black box, and those only test like one happy path and one sad path. And then we've got some integration level tests, and they test like, okay, well, what happens if the connection fails, and what happens if the database is broken? There's actually a test in there which like calls an API method and then deletes a database table, and then calls another API method and says, yes, that should have errored. That was the easiest thing we could come up with of simulating a database failure. And then we have a lot more tests, like say so that pull request I actually merged just now was adding a load of like sort of data level unit tests that do test the validation. So when you're picking a resource class and sending it into our system, is it matching the correct validation rules? And so we just added another 10 or so test cases onto that. This particular app's written in Go, so it's pretty fast in terms of like straight line speed, and it has some nice startup times. Although actually, when you've got a test suite that only takes like a few seconds, the overhead of Go's compilation time actually adds up quite a lot. But yeah, did I answer the question?
Well, I have a question about that. So we're talking about, making our tests faster, and then, but there is the reality that, depending on how your executors are configured, right? So I'm speaking to more of the, there's time consumed and leveraging caching. So there's time consumed installing dependencies, right? Some people like a clean slate and they like to build out, the environment, the runtime in every build. I'm kind of, I'm a fan of that personally, but I understand like where, if you have to pick and choose your battles. And I just wanted you to talk about like how, that kind of impacts that 1 minute rule, and how we could leverage maybe, a happy medium between doing some of that live or in the build installation dependencies and stuff, and then maybe having some of that already in the cache, right, mechanism that we have at Circle.
Yeah. So I think that can be answered at a bunch of different levels. So in terms of like just making a test, so in terms of making a test suite that you're going to run locally fast, one of the main things we do is try and minimize the number of things it depends on. So in order to test this particular repo, because it does use the database, like there's like a Docker compose file, so I have to do Docker compose up, and I've got my database running. I think we actually configure that database to use a RAM disk, just because like it's for testing. We don't need to put these bytes on disk, so that gains us a sort of a few milliseconds here and there probably. And then one of the things we've got is, so the tests themselves will set up the database schema beforehand. And we've actually got a thing in this particular test suite where we randomly generate a database name. So we create multiple databases, which allows to make sure things are nice and isolated. What we don't do in this particular test suite is we don't add loads of data into that database. So we're not really doing any performance testing in this part of the system yet. If we were to do some performance testing, we would mark that as a separate test suite, and we would have that run in isolation. And then in CI, we'd run that in parallel so that the performance tests spin themselves up and so on. And again, we're kind of lucky in this case because it's a Go app. Then we don't require a lot of system dependencies. Go apps are pretty self-contained dependency-wise. We're only talking to one database. One thing that is worth talking about there, I suppose, is with this being a sort of a microservice architecture we've got at CircleCI, so various teams have their own different services that they talk to. So in production, the service here talks to 4 or 5 other services across CircleCI to handle things like authentication, authorization, long-term storage of information about builds and so on. And in this test suite, we have stub versions of all of those in it. Like we've got a copy of the interface, and we've built our own in-memory version of each of those services inside this code base. So it does mean that if a change is made on the other side, then our test won't catch it. And we've got some other types of tests which cover those scenarios. But in terms of the core test suite, we're testing against the stub. And then in terms of like the system dependencies, I'm definitely in the camp of I want to start from a clean slate, and I want to install those dependencies in the build declaratively using infrastructure as code. Like I don't want to make any assumptions about what's running on the machine. But then you can leverage, so I guess CircleCI cache as a good. Interestingly, we discovered that with modern versions of Go, using the dependency proxy is actually just as fast as using CircleCI caching. So we took the cache out, and that was handy. And then I guess the other thing you do is if you've got a really complicated set of dependencies that you require from your builds and you want to save a bit of time, is you can then pre-build a custom Docker image and sort of launch off that. And you still have to pay the time to download that Docker image, but you don't have to spend time compiling or installing stuff. So that should pay back a little bit.
What do you mean by a dependency proxy in this case?
So in particular, like in Go 1.13, they released a new way of doing package management, which is like, it used to be every dependency got git cloned, and unsurprisingly, that was a little bit slow. And now they've got there's a server which will just give you like the 2 files you actually cared about.
That's awesome. Thank you.
Thanks, Anna.
Yeah, thanks for your question, Hannah. And looks like David had a question here. David, why don't you ask your question?
Awesome. Yeah. I was just wondering, so you mentioned those larger tests where you aren't stubbing out the external services that each of your microservices is calling. It doesn't seem like those are running on each PR. Is that correct?
Broadly, yes, they're not running on each PR at the moment. The answer varies depending on which repository I'm talking about. So this particular one, where this is the one where we've been most adamant about let's keep this fast, doesn't currently do that. What we are working on is something that will do that. And if we look at our sort of nearest neighbor dependencies, like 2 or 3 of them are very fast to start up and have minimal dependencies. So we're going to prioritize like running those ones as part of the build. And the ones that are a bit slower and have been around a bit longer, we're currently going to continue to use stubs for those. And generally, those are the areas where we have to use sort of, I guess, rely on ourselves being really careful about the contracts on the client and the server side, and also using like canary production deployment techniques. So there's been a few times recently we've talked about we keep referring it to as the channel tunnel. So I don't know if you don't know the history about this. So the UK, where I am, is connected to France by a tunnel, and they started building that tunnel from the French side and the English side at the same time, and they didn't quite meet in the middle. But when they got close enough, I think the story goes, they managed to shine a laser through some stuff, and then they just sort of adjusted a bit to meet in the middle. And this is something we've ended up doing a few times recently. So we've spec'd out how something should work. We've gone and built the server side. We've gone and built the client side. We've shipped it into production, and we've missed a little bit. And then we've just like adjusted things to match. But the way we've structured our change is so that shipping that into production didn't cause a problem for anyone. It just quietly failed, or it's a new bit of functionality that sort of it sent a new field that was ignored by the server, but the server still handled the old case. So generally, yeah, like where we can get the speed and the feedback, then we will try and test against the real thing. and where we think doing that would effectively slow the build down, that would add a drag to all of the other types of change we want to make. So it just means that we have to take a little bit more care when we're making changes to that part of the system. Does that answer the question?
Yeah, I think it does. Thank you very much.
Cool.
Yeah. Thanks, David. All right, so let's, yeah, good question so far. All right, so Glenn, can you, so kind of going through some of the stuff you talked through so far, what are, if we're trying to jump into, trying to optimize our builds and make sure that we're getting to this ideal, 1 minute target that you have, which tall order for a lot of things. How do we know kind of what to focus on first?
Yeah. So I guess the first thing to do is to try and measure things. So I know we've got a feature that at the moment that's kind of in an early preview of the Insights. Well, it's public now, but I think people are still trying to kick in the tires on it and understanding what's possible with it. But we've got the V2 API Insights endpoints, which allow you to like aggregate times across your workflow and see which jobs are the slowest. But what I like to do is to just look at that workflow graph. In fact, let me share my screen again. I'll point to that graph I had up a minute.
Yeah, that'd be
great,
cool.
Show
us some graphs.
It's this one, yeah.
You have
so
you have the coolest graphs.
So this is the graph here, and like you can see, like I've got this lint job here sitting on its own, and the test job. And what I generally do is I'd look at a graph like this, and look at everywhere I've got a job is dependent on another job. Ask myself, is that really dependent on another job, or does it just feel like it should be dependent on that job? And so when I was prepping for this talk today, I was talking to Jeremy and Angel, and I was looking at this graph, and actually the database schema job here. So what that does is it runs all of our database migrations to check that they work, and it produces a SQL file so we can see a snapshot of what things are going to look like. So that was marked as a dependency of the database migration Docker image. So we build a Docker image that will apply those database migrations, and then we deploy that to production. So it felt like, yeah, I shouldn't build a Docker image unless like all my database migrations are correct. And when I was looking at this, I go, well, actually, this one was 40 seconds and that's 52 seconds. So like, if those are dependent on each other, there's no way I can get under that minute. So I broke that dependency. So I think generally what I like to do is just look at a workflow, look at this graph, like look for any big numbers and say, okay, well, like where's the time going in these tests, or is this dependency really necessary? So like at the moment, this builds job takes 30 seconds and this Docker image job takes 38 seconds. And like, is that important? Is that vital? Can I get away without that? And in this case, no, that has to be the case, because the build image is using a certain set of dependencies because it requires a Go base image, and the Docker image is using a custom image we have at CircleCI that standardizes all our build processes. But then if I go and look at the test process here, so like where did the time go running my tests? So in this particular case, this is why this was unusually slow, is I got a cache miss. So I'm using the new C image variants that the customer engineering team has recently produced, and those are designed to be much better at caching and much faster to start up. But not a lot of people are using them yet. So as more and more people start to use them, that cache will get a lot warmer. And then the rest of this time, so we spent 30 seconds running the tests. And the reason for that actually is there is a test which tests some behavior under timeouts. And that timeout in the real app is not configurable. And we were trying to decide, like, should we add a config flag just to speed up our tests? Or should we keep it realistic and only allow the real timeout value from production? And at the moment, we've stuck with, okay, no, we're not making it configurable just for testing. We're going to allow that. But I might change that because, that's way too slow. And apart from that test, the rest of the test suite runs in about 10 seconds. So that would trim that down. But yeah, on the whole, I think when we get a cache hit, this step here takes like 2 or 3 seconds, and then the whole thing generally, like it's no longer the hotspots. What I'm really interested in is there's a tool from a company called Honeycomb, which is called Build Events. Let me show you the link to this. And I'd really like to build something like this into our platform. But this is kind of like an alternative way of looking at a workflow. And they do it as this sort of tracing waterfall graph. So the idea being you can see like what is on the critical path and what's not on the critical path and see all that. And there is an orb for it. So you can use that orb, you can wrap up some commands, you can add it to your workflow, and you can get this visualization of what things are going to look like. And that can be a good way of identifying where the hotspots are. But I suspect for most people, like when you look at a graph like this, you'll see I've got one job and that job takes 10 minutes. And then I've got a few, and so part of it is starting to think about that job and saying, okay, how do we break that job apart? What work can we do in parallel? Like I've seen a lot of jobs where it's like they do a checkout and then they do a lint and then they do a test and then they do an integration test and then they build a Docker image. That makes perfect sense. Like it's a good way to get going. But if you're really looking to eke out that extra bit of speed, you can split those things into separate jobs. And especially if you use popular Docker images as the base, then the overhead of starting those jobs will be quite low. And there is an overhead, so this isn't free. It won't always speed up your build, but there's a lot of stuff you can play around with and just reshuffling those pipelines.
Yeah, I always have from I guess a confidence kind of perspective. So this is great, and you kind of actually shine a little bit, shown a little bit of shined a little bit of a light out for me at least regarding the decomposing certain tasks. So I think at least I am, just because I've come up through software for the past 26 years, right? And yeah, the mindset has to, at least my mindset has to kind of understand these new ways of doing, but so I was waterfall all the way, and then working towards agile. So I have a unique, well, very unique perspective because of just the amount of time I've been in the industry. So a lot of times it's hard to break those kind of the break down that whole mindset to adopt these new trends, right? And that actually first of all, you just have to, again, get your mind around it and learn it, and then understand the differences. What do you recommend for folks like myself, who are just kind of trained one way, and what do you recommend for like a person like yourself to kind of break that
habits,
conditioning, I guess I'm
yeah.
trying to say. Do you have any
Yeah.
tips or advice on that?
So I get asked questions like this relatively often. People are like, oh yeah, how did you learn to do this? And how did you learn to do this? And how did you learn to do this? And I don't actually have a good answer to any of these things. Like I didn't keep good notes, or I don't remember. I guess the not very useful but most accurate answer is gradually over time. And I guess I was fortunate enough to work with people who valued these things, or to have jobs where I had enough slack time that we weren't just constantly under the crunch, so I could start saying, hey, what if this was better, and doing some research in that area. I think going to conferences, being exposed to some new ideas, and treating conferences generally as a way to find out about things you didn't know about is really powerful. And I think especially at the moment where more and more conferences are going remote, that's a great opportunity to discover these things. So whenever when I do go to a conference, I always try and look for something that's a bit out there, or some conferences with a bit of fun in them. I think CraftConf was a really good one for this sort of I think it originally came out of the craftsmanship movement, but I think they've expanded from that a little bit more, and it's generally talking about taking care and really sort of digging in deep on certain aspects of software development and understanding what you can get out of that.
Yeah, that sounds right. For me, I think once a lot of it's okay, reading about it's one thing, but then putting it in practice is another. So yeah, I'll spin up a new project, right, and just go ham on it and see how the actual concept is put down into actual principles, right, and then procedure and then code. But can you bring that the graph up again that we were looking at about the
sure.
CircleCI dashboard? I did have a question about failing.
I was going to say, to your point there, when you were talking about I guess experimenting with things, I was very fortunate in that I had a lot of time on my hands, and I was able to get involved with various open source projects, and quite a variety of them as well. So you got to see lots of projects doing things in a slightly different way, and you get exposed to ideas that way. And then likewise in my work, being a consultant, I would do a few months or a few weeks at a client at a time, and then I'd move on. And through that, I was able to get exposed to a lot of different ideas in a very short space of time. So I think definitely if you've got the time, if you've got the capacity, then getting involved in open source or just seeing what's out there is a good way of saying, because you get people who've worked at a single company for 4 or 5 years, and I'm not saying that's a bad thing, but they won't have been exposed to any ideas apart from the ideas at that company. Like you have no yardstick to measure yourself against if you only see one thing.
Absolutely. Yeah, I definitely believe in getting your hands dirty, right, to understand these kind of philosophical concepts and how you can implement them, how they're actually executed and implemented, right?
Exactly
so
that, right? Yeah, and if you've got a side project, like you can throw it up on GitHub. If you mark it as like public, you get like 4x parallelism on CircleCI, so you can start to play with these ideas. If you mark it as private, you only get 1x, so you can't really parallelize it. So yeah.
Right. Yeah, there's a little hack tricks there to get more bandwidth on Circle. Open source all your stuff if you can. My question though is on so if we're looking at the middle set of tasks there, I guess, yeah, right, the middle one with migrator image. So my question is, so let's say, you know, I decomposed all my tasks a lot, you know, to actually run faster. That means I have to kind of change the dependencies of my workflows, right? What job depends on what other job. So let's say, all right, good example. If I'm in this middle column there and I'm at the bottom with testing, if any of those fail, that means the whole build fails, right?
Yeah. And so generally what I'm looking at is the pull request status on the pull request. So if I go sort of back to this pull request here, you can see that I think I've rebased all the commits that failed, but each and this is actually the way I get to CircleCI the most, is through GitHub. So our workflow is very pull request centric. So generally, and it's kind of buried a bit, and it's not the most discoverable, but it's there once you know it's there, like you start using it all the time. But yeah, if you click these little commit statuses in GitHub, and these appear on like the commit view, on the branch view, they're all over the place in GitHub, and these let you see all of the individual jobs that ran and the result of them. So we'd get a red X there if any one of these failed. I'm sure I can probably find a failing one down here.
Yeah, there you go.
There we go. I'm sure Dan, hopefully Dan doesn't mind. There we go. So there, like my test failed with CircleCI, and I got all these ticks. And then depending on the repository, we'll have some of these checks set up as required, requirements to merge a pull request. So if this job hasn't passed, then you can't merge the pull request. Although generally between ourselves, like we wouldn't merge it if there was something failing.
Right. Yeah, and the reason I ask is, so how do I? Let's say I don't care if my lint Helm chart doesn't pass. How would I go about orchestrating it and then not having that dependency? I guess unlinking the requires of the deploy, maybe.
Yeah, that's the simplest thing. So in this case, this verify generated step here. So what that does is we've actually got a bit of generated code in this repository because that's just how Go does things. And there's a common convention where when you clone a repo, you shouldn't have to generate a bunch of code. It should just be there. But what you want to make sure is that if I ran the tooling to generate that code, I'd get the same code. So this job here runs on CI. It installs some protobus stuff. It generates all the code, and then it basically does a git diff and says, like, is this in sync? And that is, I don't know whether we did this on purpose or that's just the way it is and it's convenient for this demo, but that is not a dependency of the deploy job. Maybe it should be, but it's not. Like realistically, we'd be unlikely to merge with that failing unless we were in like an emergency scenario, at which point like we'd probably want to override it. So basically it's really up to you, like which jobs depend on which jobs and deciding what's important to you. Like one of our repositories that deals with provisioning virtual machines with our cloud providers, sometimes the cloud provider runs out of VMs, so that job fails. So we don't have that job marked as a hard dependency on the deployment. So when you're looking at pull request, that job fails, you can look into it and go, well, that spent 10 minutes waiting for a VM and then gave up. I'm going to merge this anyway.
Right. Because it's a dependency that's not critical and it's pretty much out of your control.
Yeah, exactly that. And there's definitely some things where you're like, okay, we are going to enforce this via the tool. We're going to make sure that no one can bypass this. But there's a lot more stuff where we just allow humans to enforce it. Like we have a process, the process is documented and we follow the process in the majority of cases. But this is a thing I believe a lot about processes. Like you don't have to encode every bit of your process in a tool because that takes away the ability for humans to make decisions. And even if you're in like a really highly regulated environment, that's still the way things are done. Like most finance processes are done by people like adding things up on spreadsheets, and that's okay as long as they follow the process. And in the rare occasions you have to step outside the process, you have a very good reason, which you just sort of document appropriately. And generally, so you can be audit compliant and not have your tools enforce every single aspect of your process.
Absolutely. I think we have I'm not sure if Glenn's the right person for it, but there is a question about, so how can we achieve instrumentation testing with Android emulator? I'm not sure you're the right person, but do you know anything about that?
I know a little bit about Android emulator. So I know, I'm pretty sure it will run under QEMU on our current platform, but it's a bit slow. And I know there are some sort of third-party hosting providers which you can plug into CircleCI, which they host all the Android emulators, and you can connect across. There is an item way down our roadmap somewhere where, like, wouldn't it be nice if this worked natively? I think the blocker for that is getting nested virtualization enabled on our cloud provider, and that reduces the number of VMs we can make available. So maybe we have to make another resource class. So so yeah, if you're interested in Android testing, then I think there should be an idea on it over on our ideas website. Make sure you upvote that, put a comment in, especially if you're logged in with an account that's associated with your employer and your employer is paying us money, because like the customers, like when we prioritize what we're going to build, it's like, who's this going to help the most? How is it going to help us grow our business? Because at the end of the day, like, we want to still be around so we can keep running everyone's builds.
Absolutely. Yeah, makes sense. So I don't have any really questions from the audience. I wish there were more, but let's go ahead and there's one here that I have on my mind is, so what's the highest impact? Sorry, go ahead.
I was just going to say, I see a former colleague of mine, Andy, in the attendees list. So come on, Andy, give us a question.
All right, there you go. Let's pick on Andy. Is it Andy Mark?
Yeah.
Oh, he's ready to go. Andy's shy. All right. Well, while Andy's thinking of a question, I'll go ahead and ask mine. So, what's the highest impact change that someone can make, right, to their builds right now? I know that's a kind of an open-ended question, but I think in an abstract, what could someone do to get a high impact?
So I'm going to have to give a really consultant answer on this one and say it depends. And so
it's all good.
So the first thing you can do is like go measure it, go find out what your hotspot is, and go figure out like what's the problem. Like if you're spending a lot of time per build like downloading dependencies, then maybe look into CircleCI caching. We've just released a new feature recently on our Docker executor where we make a RAM disk available to every build. So if you're looking at your job and you're saying, oh, like the thing that's slow appears to be like working with the disk, and that actually includes caching. Like if you've got a massive dependency cache and you want to write that to disk reliably, then like with our sort of like cloud platform being like cloudy weather, as I like to call it, like you can't necessarily rely on the disk always being really, really fast. But RAM is always fast. So what we decided to do is we make this RAM disk available. And if you download your dependencies or you do your like heavy file system operations on that RAM disk, then that can speed up your build by quite a big chunk. If you're using Docker, then we've got a product called Dakahliya Caching, which is pretty much we get a disk with our cloud provider and we plug it in, and then we run your stuff, and then we plug it out, and then when you run another build, we plug it in again. And so that's really, really effective at speeding things up. It comes with its own set of pitfalls and problems, but like there's a trade-off to make there, and sometimes that's the right trade-off. If your builds are, say, CPU limited, then we can offer you larger resource classes and give it more parallelism. If you've got so in the early days of CircleCI, a lot of our jobs or a lot of our customers were running Rails apps, and fairly large ones at that. And that led to us developing the feature we call test splitting. And this is generally like you've got a large test suite. Each test is individually like not super fast, but also not super slow. And you want to say, how do I spread that around? And so rather than forcing you to decide, okay, well, I'm going to run these in this job and these in this job and these in this job, we take the JUnit XML output from a previous build, and we use that to get a list of tests and how long they're going to take. And then test splitting is able to look at that list and allocate them appropriately into equal size buckets. So I think there was a blog post back towards the back end of last year explaining how all that kind of works and fits together. But effectively, you take a single job, you set parallelism 10, and you do a little bit of sprinkle a bit of magic into your test runner to say use CircleCI test splitting, and ta-da, you're almost 10 times faster. There's a thing called Amdahl's law, which is like the more you parallelize something, the more the synchronous bit becomes a problem.
Right.
So you can't just speed it up indefinitely. But I actually saw a customer a while ago that was running 200x parallelism on a single job, and I was like, surely that can't be faster than running like 20 or 50. And I checked, and no, yeah, it was actually faster for them. So more power to them.
So you had more horsepower, yeah.
Yeah, pretty much.
Yeah, those are always hard to kind of, like you said, you definitely have to have measurement metrics, right, to telemetry to make the right decisions, and then you also have to be taking measurements on the appropriate data top points, right? So if you're not measuring the right thing and you're optimizing for the wrong thing, yeah, you're not going to speed anything up. Probably make it slower in some cases. So
we have another
there was
question.
Yeah, go ahead, Jeremy.
So does CircleCI recommend any practices for using their product with mono repos?
Good old mono repos.
Good old mono repos.
Mono repos themselves is a whole nother, probably a whole nother session.
That's a whole nother session.
Yeah.
But
so let me split my answer into two. So this is the I'll give you the CircleCI answer.
So okay, so your mono, you're doing all of it into one question.
Yeah. So I'll talk about like what CircleCI recommends, but I'll talk about what I personally recommend first, which is, and I see this quite a lot, which is people adopting like monorepo patterns. So monorepo patterns came out of companies like Facebook and Google, where they had this big repo and they had this big team of release engineers who papered over all the problems you get when you try and do a big monorepo. And I think a lot of small companies don't have that, and they don't have it doesn't make sense for them to have that. So a lot of people I see sort of adopting monorepos and hitting all these tooling and problem and issues are like almost, they're self-inflicted, and it feels really harsh to say that, but like to a certain extent, like sometimes the monorepo problems are because you shouldn't have had a monorepo, and that depends what you mean by a monorepo. So one thing I see a lot is like 20 different projects all in one Git repo, and there's some benefits of doing that, and there's also a lot of drawbacks, and I guess it's up to you to decide where you want to sit on that scale.
Right.
In a CircleCI sense, I guess you can run each of those subfolders as a separate job. And the request we get a lot from customers is, okay, well, how do I only run the test for the bits that have changed? And today, the easiest way to do that is to put them in different Git repositories. But it is possible with CircleCI to actually like tidy them up a bit. We are working and sort of doing some research about how can we handle this better. But currently there's I'm trying to remember where we've written that up, but there's a way to abort a job early with success. And if you use that in combination with, so it's called CircleCI task halt. It's like you basically run this command and that will like stop your job early. And if you use that and you put that in each of the jobs, you can say, okay, well, when did this last change? And then sort of just stop that thing. One thing to watch out for is that works at the job level, not the workflow level. So that will still pass, that job will still pass, and it will still continue on to run the rest of the workflow. And I think one of the reasons we haven't managed to sort of add a core feature to our product yet is all the research we've done has basically said this is complicated. So an interesting thing is, so what I said earlier was like, you can decide whether to run it if something has changed. But when we've spoken to a bunch of different customers, like what changed has a very different meaning depending on who you are. So does it mean like what's contained in the pull request? Does it mean the difference between what's in the pull request and what's on master? Does it mean the difference of the new commits only between what's on master and what's in the pull request? Or does it mean actually I want to go call out to my production deployment system and say what version is deployed right now? And I want to run the set of changes between production and my branch. So we're kicking some ideas around internally. We're trying to figure out how do we solve for all of those use cases rather than just solving for only one of those use cases at a time. We have some ideas, but they're all very, very early stage right now. So I hope that answered the question and didn't offend anyone too much.
No, yeah. So just talking to your point though. So when I was working in the federal government, I was in charge of tons of resources, right? Like thousands of machines. And yeah, we this was in early 2009 or 10. Anyway, so there, right, this concept of Google for everyone, I remember that term being thrown around at conferences like wildfire, right, during that time period. And when I was working obviously in the federal government, that made sense, right? Like that operating that way was pretty much like, learning from Google and how they were doing matched exactly what I was doing. And then when I left the federal government, started working with startups, I tried to bring that kind of mentality to the startup. It's like, whoa, man, we have no money for this, right? It's a whole different, and we don't even have the volume, right? So I had to adjust my mindset and the way I was thinking about infrastructure and testing and all that stuff, right? And not basically shy away from the Google for everyone. So it is different for everyone. But I believe also with mono repos, right? I think folks that are, smaller companies are just trying to adopt these Google-esque or Facebook-esque type infrastructure management type, philosophies. But the reality is they're just not going to work for you. And I think they do it in hopes of like kind of future proofing, right? Their infrastructures. That's what I was trying to establish, right, when I was in the small startup. So what is some of the, I guess maybe some advice you can give on future proofing, right? Like I learned, that I had to focus on the problem that I had at hand and then, grow the infrastructure to where it needed to be eventually, right? As the business dictated.
Yeah, it's a good question. It's actually making me realize that. So although I've said like I'm not a big fan of the mono repo pattern where you have a Git repo with loads of entirely unrelated projects in it. What we have actually started doing in my team recently is we've been dialing back our microservices a bit. And I've seen a bunch of buzz in this in the tech community recently, like right-size services. It's like, well, we didn't intentionally make them wrong, but okay, fine. But yeah, this idea that like just because you can doesn't mean it should be a service. And right. Every time you go over a network hop, that has a cost. Every time you have a dependency contract between two Git repositories, that's a cost. So trying to have having a repo that contains like one app and that app doing a bunch of stuff, I think is okay. Like in my book, that's fine. It's when you start having unrelated things in the same Git repository and then you're trying to relate that life cycle that gets a bit tricky. And especially, I think it gives you this fiction that the deployment is atomic, because unless you're going to turn everything off and then deploy and then turn everything back on, which I think most SaaS companies don't do anymore, then like if you make a commit to two different subfolders in that repository, when you deploy them, they do not deploy at the same time. Like you have to be able to handle that intermediary state. Yep. And so that's why almost to some extent, splitting those into separate repositories forces you to remember, oh no, I can't just change these in one go. And then I guess part of it is also getting better at defining those boundaries so that you don't need to change things in one go. Like I update the client to start sending a new field. I then update the server to start handling that new field, and then so on, those sorts of patterns. Yep. And I guess in terms of future proofing, so I've been talking to a few people recently about solid. So solid is this like concept from object-oriented programming that all the letters stand for something, but it's all about like building your objects in a way that can be plugged together. They have this open close principle, which is that things are open for extension but closed for editing, and I reject that notion entirely. So I'm really big on malleability of code. Like code should be easy to change. We should be structuring it so that it's not connected to too many different things. So we've got a well-defined boundary and we're testing at the boundary, not testing at the implementation detail. And that will allow us to go into a module, change it as we need, make sure it still does what it needed to and does what it needs to do now via tests, and then push that out there and keep constantly editing your system. So I think to me, a lot of like future proofing isn't setting up your systems so that they can be extended and plugged in. It's setting them up so that you can just go in and change them when you know more. Because certainly at the start of a project, that's when you know the least about it.
Yeah, for sure. Yeah, thanks. Good answer. I don't see any more questions. We're getting close to time.
So how fast are our pipelines internally, Glenn?
It varies quite a lot. So I think like this one I've been showing today is one of our faster ones. It's usually around a minute or 2 minutes today, just to screw with my demo. I think the slowest one we have, well, so the slowest like application one we have is around 8 minutes, and I think that uses some test splitting to keep it pretty snappy, to sort of take a few minutes off the time. We do have some that will take a few hours, and those are generally involving like building VM-based images. So the job that builds a brand new Windows image has to like download Windows and install Windows, and then install all the updates, and then install some GPU drivers and so on. So that one takes a couple of hours, and there's not a lot I can do about that. But yeah, so it varies a lot depending on the project you're working at, but certainly the things that we're changing the most often are the ones we want to get the fastest feedback on, and that's where we really sort of spend our time optimizing for. Yeah, and I think generally we sort of split things into separate repositories so that each individual set of changes can be quite isolated, and we don't have to. So, for instance, when I deploy this application, I don't rebuild the Windows image because, like, that would be a waste of time. And
Right.
generally trying to find those seams between our services, where which services does it make sense to test in concert, and which services does it make sense to think about and operate independently.
Got it. Okay. Okay, so how about the last one last question I had kind of written down, kind of a last little thing, like what can CircleCI do to help speed up builds overall? Like a pretty broad question, but what are some key things that we can do to help speed up builds that people have?
Yeah, I think so. I think someone in the docs team is working on like I think it's like an optimization cookbook, where they're going to try and put all these things down in one place. But every time we do it, we keep getting carried away with new ideas, and we need to start shipping some of that, I guess. But yeah, I think generally the biggest thing is picking a good Docker base image. Like if you are starting a build and then you're starting from like Ubuntu base, and then you're installing like Ruby and Passenger and all this sort of stuff, then you're gonna have to wait a while. So I think picking a good base image is really important. So if you're testing, if you've got a Python 3 application, taking CircleCI Python 3 would be a great choice. And often that means that there will be a bit of a difference between what you're testing on CircleCI and what you're running in production. And that can be a bad thing, or sometimes it can be a good thing. So I have this theory that like, if we all use the exact same version of everything, then we'll accidentally code to some things that are quirks about that exact same version. Whereas if we use roughly the same version, we'll probably be okay. And I change my mind about that every now and then, but that's where I currently am.
Okay.
Yeah, so I think getting a good Docker base image, generally using our Docker executor, you will get slightly faster startup times and a few more features than our machine executor. Although sometimes you really do need to just take control of the whole machine, and that's why we have machine as an offering. Caching, certainly. So if you're spending time downloading dependencies, you're downloading the same thing between builds, then using the caching. So that allows us to download directly from S3 object storage in the same region. So I think, yeah, like especially if you need to download something from like not in the Eastern US, then you will get a big speed up from using caching. Yeah, the thing I was talking about earlier about making your pipelines kind of shorter and wider, I think that's a big thing you can do. Test splitting that I talked about earlier is a nice way. So if you've got a test job with a lot of tests in, test splitting is a great way to speed that up. Dakahliya Caching, again, if you're building a Docker image, have a look at Dakahliya Caching. We've also got an orb we're working on that uses a Docker registry caching feature. So rather than plugging in a disk in and out, which has issues with concurrency, you can use the Docker registry as a cache. So certainly if you're doing any like compilation steps in the process of your Docker build, then that's when you really benefit from using registry caching, because you can download a pre-built image from a previous job. The RAM disk, that's a nice new one that you can play around with. So if you're doing like, if you're downloading a lot of dependencies, or you're doing a lot of stuff on disk, you're really hitting the disk hard, then look into the RAM disk. And actually one thing I don't see a lot of people doing a lot of is parallelizing within a single job. So if you take like a test runner like Jest, for example, Jest is able to split the tests in a single process across a number of cores. And so on our Docker executor, you can request a larger machine. So the standard is a medium, and you can get like a large machine or an extra large, or I think if you ask us, we'll give you a 2 extra large or a 2 extra large plus, which are really it's a really big slice of the underlying node. And then you can set that job to like I guess the classic one, if you're running make, you can set make -j and say like 20, and okay, well, let's just use 20 cores and see what happens. Yeah, so I think those are all the sort of the things I would think of that CircleCI features that can really help you speed up your builds. I guess there's a lot of stuff there, so I'm really hoping we can flesh out the area of the docs to give you like here's a hit list of things to try if you want to speed up your build.
Yeah, that's
Got
probably a good another good blog post, right, or something.
Yeah.
So
Yeah,
I do have one question I want to tease out before we go. I know we're coming up on the hour, but that you just mentioned something that kind of sparked the light bulb. So yeah, there is something to be said though, right, about what you just talked about with Jest, and then utilizing, I would say, the application testing, right, configuring it to you leverage, right, the concurrency if it supports. So not all stacks support that, but if it does, right, that should actually be, that's actually a thing I did like kind of 5 years ago in an application that was like, it was a huge, test, very comprehensive testing. And then I just said, well, let's start leveraging, right? We're using one thread. And we broke that out, started, leveraging, yeah, using the cores, and then just basically configuring the test suite to actually, leverage concurrency and running those tests and using all the cores. Because believe it or not, a lot of developers don't really go that deep in, right? It's only like a very few, and sometimes it's mainly the operators that are like, whoa, this is so slow, and you're not even, it's the people that know and have the experience with like the hardware and understand, right, how those CPUs are actually running, and then it takes the developer who has the subject matter knowledge in the stack to kind of come together. And that's how I was more on the operations side, and then I'm like telling my application folks, hey, we need to like leverage these cores. I have this beautiful server sitting here, and we're not, it's underutilized, and because they're asking for more resources, and I'm like, I can't afford it because you're not even using what you've got. So these are realistic kind of situations that folks don't really even, I don't think they understand until they're trying to spend more money and unjustifiably.
Yeah, I mean, even the standard CircleCI executor, you get 2 CPUs and 4 gig of RAM, and like I think we give you some burst capacity as well. So if you use a bit more than 2 CPUs, you can probably have it if no one else is using it. So yeah, like using those CPUs, and I guess in the sense of tests, the hardest thing there when you want to parallelize tests in the same container is making sure you're not colliding with each other on states. So any tests which aren't touching the database, they're a good candidate for running in a separate process. And when they are touching the database, then you can use tricks kind of like the one we've done here, where each test uses its own copy of the database, and that can work quite effectively as well.
Right. Yeah. Awesome.
Cool. All right. Well, so that kind of puts us where we are at the end